12C. Find the volume of the region bounded by these curves, revolved around the line y equals -1. Let's begin with a picture. So we have our region. We'll be revolving vertically around this axis, y equals -1. And notice that this point of intersection is actually above the line. So we're going to need to find where these two curves intersect for our limits of integration. This is a calculator problem. So graphing y equals x squared minus 1 and graphing y equals the square root of x and y equals negative square root of x. We can find these intersection points here. I'm going to use the calculator to store these exact values in a and b. And when we write the expression, we'll just use a and b. So let's consider our representative rectangles, which will be like these. They will be revolving around the line y equals -1, forming washers, which will look like this. Oh, and I should say that when we found those intersection points, we didn't need the y values, only the x values, because our representative rectangles were dx's, and we just need the x values for limits of integration. All right, so we'll find the volume of this washer. That's a result of rotating that rectangle around this horizontal line. And then we'll accumulate the volumes of all those washers for all those representative rectangles that we could draw in there. However, the representative rectangles have different boundaries before this x value versus after the x value. After this x value, the representative rectangles had an upper bound that was the blue curve and a lower bound that was the yellow curve. But before this x value, x equals a, the representative rectangles had an upper bound that was the blue curve and a lower bound that was the blue curve. So we have to do two separate regions. So the overall volume will be the accumulation of all of the washers' volumes from x equals 0 to x equals a, plus the accumulation of all of the washers' volumes from a to b. And recall why this formula makes sense. Let's consider this disk, for example. To get that washer, we don't want the inside, so we take the entire disk, which is pi times r squared times the height, and we subtract the inner disk, which is also a disk whose volume is pi times r squared times height. And that would give us the washer in pink. So that's why this works. So this problem boils down to, at this point, finding expressions for the large and small radius of the big disk and small disk for both regions before x equals a and after x equals a. So for this representative rectangle, the outside radius, the big radius, will be the distance from this blue point to the red line. So we just subtract this y value minus that y value. So radical x minus -1. Now we need to subtract the inner washer's radius, which is the distance from that y value to this y value, and this y value is -√x. All right, this is the volume of the entire washer before x equals a. Now we have to add on the region after x equals a. So we need all these large washers. We're going to accumulate them. So let's go ahead and add the volume of those washers. So pi times radius squared. And these washers begin at x equals a and they end at x equals b. So the large outside radius, which will be the distance from the blue curve to the axis of revolution. So this y value, which is √x, minus a -1. So pi r squared dx will give us the volume of that giant washer. And then we have to subtract the inside washer, which is pi radius squared times dx. And the inside washer's radius is the distance from the bottom, which is the y value of the yellow curve, which is x squared minus 1, minus negative 1. All right, there's our little radius. That's a negative 1, not a y. All right, let's clean this up a little bit. Which lands us here, and we could stop right there. Or if this is a multiple choice question, we might simplify further, but I'm pretty happy with this. If we did combine further, we might get something like this. So the second part didn't simplify very nicely, but the first part sure did. All right, so I think I'll just stick with this answer unless there's a multiple choice and you don't see that, and maybe this would probably be the answer then. Anyway, if you look at the answer key, they gave an answer using dy's, and that solution was using the shell method, which is not in the BC curriculum, and we did not learn it. So ignore the answer that starts with 2 pi and has a single definite integral. We only learned the disk method and washer method, so our answer would be this. And if you're curious about the shell method, you can see that the answer for the shell method was simpler, because you don't have to do 2 separate regions before and after x equals a. With the shell method, you could just do a single integral. So we will be coming back and learning the shell method post AP exam, but for now, just master the disk and washer method.